What we're going to start talking about today is parallel and perpendicular lines. And we are going to identify whether they are parallel or perpendicular. The main thing you need to recognize today is anytime you're talking about parallel or perpendicular lines, it's all about the slope. So we need to first find the slope of the original line, and then we can adjust and determine the slope of the parallel or perpendicular line. Having said that, we need to be in a form where we can find the slope. My suggestion, we get into our slope-intercept form, which is y equals mx plus b, and we need to recognize that the slope is the value in front of the x. So we will be isolating y to see which one is which. And then the last little thing, you'll need to write this down. Parallel and perpendicular lines. Parallel lines, the symbol for parallel is two vertical lines just like this. Parallel lines have the same slope. And perpendicular lines have opposite or negative reciprocal, however you want to write this. They have opposite reciprocal slopes. So make sure you have these two little elements down as we move forward here. Parallel have the same slopes, parallel lines of course, and perpendicular lines have opposite reciprocal slopes. What we mean by opposite reciprocals are change the sign and flip the fraction. And you do always have a fraction. Whole numbers are a fraction as well. 5/1, as we'll see in our first example, is a fraction. So keep that in mind. Opposite reciprocals as we move forward here. So as we discussed, we first need to recognize what we're looking for. So what we're looking for is which equation of the lines is perpendicular to this line. Well, I can't do anything until I learn about the slope. And in order to learn about the slope, I need to get into slope-intercept form. So my first step is going to be to subtract the 5x from both sides. 2y equals negative 5x plus 12. Then we divide everything by 2. So y, the equation of the line that we were given is y equals negative 5/2 x plus 6. Main thing we need to recognize immediately is our slope. Our slope is negative 2/5. And we also were told that we are looking for the perpendicular line to this. Well, it's all about the slope. So my slope is negative 5/2. So let's make our conversion here. If it were parallel, we would just take that. But perpendicular lines have opposite. Well, the opposite of negative 5/2 is positive 5/2. And then the reciprocal is the flipping of the fraction 5/2. So when we flip 5/2, we have 2/5. So any line that has 2/5 as a slope is perpendicular to this. And it doesn't matter where they are on the y-intercept because they're still going to be perpendicular because it's all about the slope. So I may have a line negative 5/2. That would be a line that looks like this. Perpendicular to this would be 2/5. Well, that would be a line here or here or here. So our y-intercept doesn't matter. All that matters is the slope. So in this case, our answer would be this equation right there. We're going to go through so we can see several examples on this. So we'll move right along here. On this one, we can see that we are looking for a line parallel to the equation that we're given. So again, the first thing we need to identify is the slope. Well, in this case, the slope is getting the y by itself, so we subtract our x from either side. So we now have 3y equals negative x. And always be careful of your signs as well. It's easy to forget and lose those. And then we divide both sides by 3, because this is what's going to isolate our y value. So we see our equation for our line is negative 1/3 x, because there was a 1 in front of that x, minus 7. Now today we don't care about this y-intercept, because all we care about, again, if you haven't heard this, is the slope. So we've got a slope of negative 1/3, and we are wanting one that is parallel. Well, parallel is going to have an identical slope, so the only one that has an identical slope would be our value right here. So there's our correct answer. So this one can be, it's actually one of the easier ones when we think about it, but it's also easy to forget this because we don't practice this one as much. What we end up with here is where it asks us to find the line that is parallel to x equal to 0. Well, if we think about what x equal to anything is, we need to first draw our coordinate planes. And remember, our x's run vertically. In this case, x equal to 0 is actually right on the axis here. So regardless of where I move this line here, it's going to be an x equals. So if I want to draw a parallel to a vertical line, any vertical line will work. So I would need another x equals. So when I'm looking for parallel, I want to keep the same variable x equals. Now let's think about this while we're talking about it. Perpendicular lines. Perpendicular means they cross and form a 90-degree angle. Well, if we are crossing and forming a 90-degree angle, that means that a vertical line is perpendicular to a horizontal line. So since we draw a vertical line with x equals, we draw a horizontal line with y equals. So if this would have said perpendicular, we would have been looking for the y equals. Now this is actually the same thing, but this is going to require a little bit more work from us because it's actually giving us a line and it's asking which one of these would be, again, keyword parallel. So we're looking for one that has the same slope. And our slope is going to be positive. So we need to get y by itself. As soon as you recognize that it's not going to be parallel, you might as well stop looking. Here's what I'm talking about. So we're going to isolate the y. That's the point. So when I minus 2x over here, I'm going to end up with a negative 2x, and I'm going to end up dividing by 1 or leaving it alone, actually. So I'd end up with a negative slope. So I know this one is wrong. Same thing here. I'm going to move the x over to the other side, which would make it negative x, and then I'd be dividing a negative by a positive number. Negative divided by positive is also negative. So I'm going to just mark those out because they do not qualify as answers. So I can just periodically go through these. I'm going to move the 2x to the other side. So I end up with y equals positive 2x minus 5. Well, this one has a slope of 2, which is not the same as this. Well, that means the last one has to be correct, but let's just make sure we didn't make any mistakes. And we start by moving the x to the other side, which looks like a problem based on what I was doing earlier, because we end up with a negative x when I subtract x. But let's think about what's going to happen next. In order to get the y by itself, I need to divide by negative 2. So if I divide by negative 2, negative divided by negative is a positive. 1 divided by 2 is 1/2. So there we have our matching slope, which confirms our answer of x minus 2y. Next series of questions you can see here. You can move to yours that look the same way. But what it says is, what is the slope of a line perpendicular to a line whose equation is this? Well, this is really the same thing. It's just formatted a little differently. So don't stress yourself. Again, if you haven't heard it by now, you wake up, because the thing that we care about is the slope. And the way we get the slope is we get y by itself. In this case, I have to subtract my 4x from both sides. It's very careful on this as well that you pay attention to the signs, because the negative sign belongs to the 10y, not the 4x. So we subtract the 4x. Negative 10y equals negative 4x plus 40. We now need to divide both sides by negative 10. And we divide everything by negative 10. So what we end up with when we get y by itself is negative divided by negative is positive, and this is 4/10. And if you're wondering why I'm not reducing, I'm going to. Just give me a second here. I just wanted to make sure I didn't do too many steps at one time. So my slope after the reducing is 2/5. So remember though, this is the equation of my line. My question was, what is the line that is perpendicular to this? Well, if I have a slope of 2/5, the perpendicular line is going to be a negative reciprocal. So we flip that fraction 2/5 and call it 5/2. Again, all about the slope. Think slope all the time. Slope, slope, slope. All right, I got a couple more here. I'm going to try to pick up the pace just a little bit, make sure we get through everything. It says, what is the slope of a line parallel to this? Well, again, we need to know the slope of this one before we can find the slope of one parallel. So the first thing I'm going to do is subtract my x from both sides. We get negative 3y equals negative x minus 27. We then divide both everything, let me rephrase that, everything times negative 3. Negative divided by negative is positive, so we end up with the slope of 1/3, and you could put the x out to the side or up with the 1, it does not matter, plus 9. Says, what is the slope of a line parallel to this equation? Well, this equation has a slope of 1/3, so a parallel line will also have a slope of 1/3. And I picked the last one here because there's a little bit of a shortcut. If you're pretty good at factoring and noticing these things, if you ever notice that all of the factors have something in common, you can actually divide that out. So I notice these all have a factor of 3, so I can factor out a 3 from each of these. Thing about math, you can do whatever you want as long as it's consistent. So this ends up with a 2x plus y equals negative 21. When I subtract the 2x over, y equals negative 2x minus 21. And we are looking for a line perpendicular. Well, I have a slope of negative 2, so perpendicular to that will be the reciprocal, opposite reciprocal. So positive, remember this is 2/1, so the reciprocal is 1/2.